So I'm not going to show you the whole video, I'm just going to show some of the mechanism. So I'll speed up to twice the speed. So what the computer is doing is trying out all the different combinations. But what he came up with this neat idea is that if you eliminated impossible combination based on constraints, for example, if one end of the line is concave, the other end of the line must be concave. Cannot be one end concave, the other end convex. By eliminating those impossible cases, he was able to reduce the search from several weeks to only a few, I think a few hours at that time. So this demo just showed you how it's propagating constraint. So this is a technique that I use a lot, even today, when I come up with designs for planning and scheduling systems, where you need to solve a problem in a fraction of a second. So back then, their computers a lot slower. That's why, you know. Okay, so that was one of the pioneers. So the examples I give you are examples. There's so many work in AI, but the examples I give you are examples that I personally were affected or related to. In AI, there's a class of problems called constraint satisfaction problem, CSP, and we use that a lot. It's used for problem solving, come up with solutions to difficult problems. And basically, it's defining the problem.
Others will take over on.
That's Patrick Winston. That's Patrick Winston when he's older now. Patrick Winston is the guy that, of course, did the art. So Patrick Winston still teaches at MIT. Okay, so constraint satisfaction is you could redefine your problem-solving problem into mathematics and then use constraint as a way to solve the problem very quickly. The office mate of David Walsh was Terry Winograd, and David Walsh worked with vision. Terry Winograd said vision is important, but language is very important too. So he tried to see, can we have a computer understand our instructions? So he came up with this program called Sherlock. Some of you who does AI research know it's a classic system. You can talk to it in English. Say, pick up a red block. It would know which block is red and be able to pick it up. And just find a block which is taller than the one you're holding and put it in the box. So it has instructions. So you can ask it questions. What's on the table? You can ask it to do things. You can teach it. So you can teach it how to build a arch or a steeple, and we remember the steps. So it's a very intelligent system. That was, I think, that was in 1970. That's his thesis, 1970. So probably 40, 50 years ago. And there's a video. I'm going to show you the video. Basically, as a video showing you the human interacting. So even back then, computers are able to understand your language and be able to perform tasks. So his thesis was, we know that a computer is intelligent when the computer can translate our English into a sequence of steps and perform that steps, which means the computer actually understood what we wanted it to do. So the things that Terry Winograd did is related with planning and scheduling. So it's a branch of AI that concerns realization of strategies and action sequences. Now, so all the things that I showed you before does not seem very human-like, right? It's very mechanical, very not human. Human has the brain and wetware. So there was a big debate, or is still going on. It's called the aircraft and birds debate. If we want to fly, should we engineer a totally different solution? Like the examples I showed you before, if we want to create human intelligence, do we just create some new ideas? Or should we just follow the nature of bird? So the debate is, the engineering camp said, oh, if we follow bird, we still won't be able, we're not flying even today. But as of this year, I think there are some scientists that actually created robots that fly just like a bird, right? Some of you have seen those research. So these are big debates. So on the other side of the field is people that study AI by looking at human brains, how the human brain functions. And it's basically a big, huge, gigantic mesh of neurons and synapses. The early pioneer includes Walter Pitts and Warren McCulloch. And those two characters, some of you do AI, deep learning research. These are the first neuroscientists that created a mathematical model for neural networks or neuron. Now, the story behind these two would probably take days to talk about. They're a very interesting character. Pitts is a homeless person, truly a homeless person. He was a child prodigy, was very smart at a young age, but because he's a prodigy, he didn't kind of get along with anybody. So he ran away from home at the age of like 13 or so. And there were stories of him living in a library and just studying all the books in the library. And that was pretty interesting. So he eventually ended up in Chicago, and because he never went to school, or he could only a few years, he sneaked into University of Chicago and listened to lectures, as just a random person. So he got educated that way. Eventually, people found that he was very talented, and then MIT took him in to study for a PhD, even though he did not go to high school. So it's pretty amazing. If you're smart, you're smart. You don't really have to go to school, right? McCulloch is also a very interesting character. He's a chain smoker, and then some people say he's an alcoholic. And those two, even though despite their age differences, they got along very, very well. And they came up with, they were super interested in neurons and human brain and how it functions. They came up with a model. So a human brain neuron looks like this. This is a single neuron. And then you have other neurons sending electrical and chemical signals to the dendrites. And the energy goes into here, the nucleus. As soon as there's enough energy that passes a threshold, this neuron will shoot the energy out to other neurons. And during this process, it would possibly attenuate that signal. Realizing this fact, they came up with a mathematical model for a neuron where the inputs are the energy, and it has weights because the input from different places maybe have different strength. The neuron summarizes these energies, and once it passes a threshold, enough energy, it sends it out, possibly changed by an activation function. So this is basically the model that pretty much all machine learning uses for artificial neural network. There are differences in threshold value, differences in activation function. So this is a single neuron. Nowadays, the main difference is that besides one neuron, we have hundreds, thousands, millions, tens of millions of neurons. Besides not only 4 connections, today in deep learning, we have hundreds, thousands of connections. Totally, there may be billions of connections in a modern deep learning algorithm. So all that started 60 years ago, 50 years ago, with this simple model. For those who are not doing artificial neural network research, this might be a bit abstract. So I have some animation that I found, kind of explains.
This is a simulation of a single biological neuron. Information flows in, is processed by the neuron, and the results flow out. This gives the neuron its abilities to react based on previously learned patterns. Technology duplicates this by creating a structure that processes information like a biological neuron does, except this process is mathematical instead. Just like the biological neuron, information flows in, is processed by the artificial neuron, and the results flow out. This single process becomes a mathematical formula that can be used for simple problems. For those that are mathematically inclined, This will look similar to a polynomial. A polynomial is limited to the problems it can solve for, as shown in this graph of an order 5 polynomial. If this is all artificial intelligence could do, it wouldn't be much use. As with the brain, artificial neural networks' power is in connecting sets of neurons together in layers. When you connect them in layers, the mathematical formula becomes something like a multi-dimensional polynomial. This allows complex problems, like what is shown in this graph, to be discovered and used for our benefit. As before, information flows in and results flow out, but this time the input to the second layer is from the output of the first layer. The exact steps for a single layer are simply repeated for each layer of the neural network.
So what we have been working on, scientists doing deep learning, is trying to design how many layers you have, how many neurons in each layer, how do these neurons connect, as well as the machine learning algorithms of how to adjust these lengths, because these lengths can be strong, can be weak, and there's various learning algorithms that adjust it so that the learning precision is higher. Okay. So that's a brief introduction to deep learning. And for my work, my PhD work is a combination. So I'm halfway between a bird and a jet plane. So we use the structure of neural networks with activation and so forth. However, our nodes have meaning because we assume that those nodes would be learned eventually from other neural networks. So this is called a connectionist model or connectionist network. Okay, so that was 60, 70 years ago, not too long ago. Fast forward to today. What we have today is very similar. We built on those achievements in those past years. And what we have now is we have a lot more computing power. We have clouds. We could potentially have millions of processors. And we have a lot of faster computers, as well as huge amount of data that we could use. So with that, AI has become a lot more powerful today. Now, a lot of you probably heard about deep learning, right? Who has heard of deep learning? Deep learning? No, I'm surprised only a few of you. Deep learning is the current trend in machine learning, where we build huge artificial brains to learn. And it became famous, this unfortunately is our focus, but it became famous because of the Google brain that Google built in year 2012. The Google brain was used because they acquired YouTube. The Google brain was to recognize and categorize YouTube videos into different categories. And it happens that most of the YouTube videos were cat videos, not most, but a lot of them were cat videos. So it looked at 30 million YouTube videos and automatically categorized them into different categories. At that time, the Google brain had 1 billion connections between different neurons and I think several million neurons. And the accuracy was 75% was recognizing the cat. It's pretty impressive, huh? So 2012, now 2000, that was last year, 2016, a few years. They're using the similar mechanism to play Go. And AlphaGo, of course, I think everyone hear about AlphaGo, right? So it was pretty shocking because a lot of people doing AI work never imagined that a computer can play Go and win a human. Now, I never imagined it could happen, not in my lifetime, so I was totally shocked. And it uses similar mechanisms, a neural network, deep learning. Main differences is that it has two neural network, one to evaluate if the board decision is good or bad, and then one to decide what to do, what are the next steps. AlphaGo learn by watching humans play Go. All the humans play Go online all the time. It processes the entire historical record of human playing online. So it learned from every single game a human has played that is online available. So there's millions of games. It learned from humans. And then by learning from humans, it not just learn to mimic humans, but play better than humans. In fact, it actually came up with a new strategy that sharp, master Go players. So you talk about creativity, will AI be creative? So this is an instance where AI has created new strategies. Now for human brain, so companies are building bigger and bigger artificial brain. I think Baidu, Google, they're building brains, artificial brains that has 100 billion connections and billions of neurons. A human brain has 100 billion neurons and 1,000 trillion connections. So it sounds like it's far away, but we're not. Within maybe a decade, we can produce artificial brains that is the same capacity and speed as a human brain. Now, the AlphaGo learned by watching humans play Go, it's a historical record of human playing Go online. Tesla used machine learning to learn how to drive by watching every single Tesla driver, see how they drive, and collecting that intelligence and then sending it back out to the car. So it's pretty, it's a pretty different world now where computers are constantly learning from humans, and we're teaching AI to be smarter and smarter. Besides deep learning, big data is something that everyone hears about, right? I don't think anyone has not heard about big data. Big data is the ability to process huge amount of data, to learn from that data. One of the success cases of big data is House of Cards. Everyone seen House of Cards? Okay. House of Cards was designed by big data because it's Netflix, so it knows all the viewing habit of Netflix viewers. It knows the demographics. They know about what kind of topic they're interested in. They know about which script writer has the best script. They know which director is the most popular. They know about which actor. Using a lot of big data and computer processing and AI, they decided this TV series should be a hit. And it did become a hit. So this is one of the success stories for big data. Big data is used for a lot of things to predict. So the predictive whether a TV show will be successful. And then Spencer is going to talk about how to use big data to predict when there might be problems with machines and fix it before the machines break down. Big data in the future could be used to predict when you might get sick, so that advise you to go see a doctor. So potentially with big data and predictive analytics, no one will get sick in the future because they will know beforehand and advise you to see a doctor before you get serious. Now, Minority Report, again, even though this is a newer movie to me, I asked a lot of young people if they never heard of this movie. It's Tom Cruise movie. I thought everyone knows the Tom Cruise movie. How many of you know Minority Report? Oh wow, very good. 5 people, 6, 7. Okay. So in Minority Report, there is no more crime in the world because prediction, they could predict crime before it happens. In the movie, it's not AI, but people are using AI to predict crime and prevent it from happening now. A lot of police departments are using that. And I just have this IBM commercial which kind of explains predictive analytics.
I used to think my job was all about arrests, chasing bad guys. Now I see my work differently. We analyze crime data, spot patterns, and figure out where to send patrols. It's helped some U.S. cities cut serious crime by up to 30%. By stopping it before it happens. Let's build a smarter planet.
So that is actually happening. There's systems, police department are using these systems. And you can ask the AI, hour by hour, at this hour, which district within the city is most likely there will be crimes. And that's how police are dispatched. In the olden days, police would just go to fixed schedule regardless, but now they are based on AI prediction. Cognitive computing is a new term that some of you heard. IBM is pushing cognitive computing a lot. It's the IBM Watson. IBM Watson is different from the other computers in that it uses a wide variety of different techniques and knowledge sources. Basically, it has access to all online knowledge sources. For example, all the encyclopedias in the world, all the Wikipedia, all the for medicines, it could be all the medical textbooks, you name it. And it uses different techniques depending on needs. So it does pattern recognition, it does vision, it does basically trying to mimic how a human does problem solving using different techniques. IBM Watson got started by playing a game. It's called, it's a TV show that's very popular in the United States called Jeopardy. Some of you heard Jeopardy. It's basically an IQ game, IQ question. And the contestants try to guess the IQ questions as fast as they could. So I'm going to show you. This is the first time that a computer can beat human beings at answering IQ questions. IQ question is tricky because it could be a wide variety of subjects. It could be a subject on history, geography, music, you name it. And because IBM Watson has connection to all online knowledge sources, it makes it able to answer questions much better than human beings.
I remember that morning going to the lab and I was thinking, this is it. This is the last Jeopardy game.
This is Jeopardy, the IBM Challenge. Here we go. Brad, if you're ready, make your first choice.
Let's take alternate meanings for 200, Alex.
Four-letter word for a vantage point or a belief. Brad.
What is a view?
Yes.
After the first clue of the game, which Brad won, I had just this horrible feeling at that moment that he was as good as everyone said he was, and he was just going to run the whole board on us.
Watson.
What is Chun?
You are right.
We actually took the lead. We were ahead of them, but then we started getting some questions wrong.
Watson.
What is leg?
No, I'm sorry, I can't accept that.
What is 1920s?
No.
What is cheek?
No, sorry. Brad.
What is class?
Class, you got it. Watson.
What is Sauron?
Sauron is right, and that puts you into a tie for the lead with Brad.
The Double Jeopardy round of the first game, I thought was phenomenal.
Watson went on a tear.
Watson.
Who is Franz Liszt?
You are right.
What is violin?
Good.
Who is the church lady?
Yes. Watson.
What is narcolepsy?
You are right, and with that, you move to $36,681.
The risk was, Ken gets a daily double, that's big, gets it right, he's going to be well ahead. And then with that kind of lead going to Final Jeopardy, if he bets enough, he could end up winning the match.
Ken.
What's a committee? We gotta find that last daily double. We gotta find that last daily double.
It was a crucial moment in the game. There was still a daily double on the board, and it was starting to become pretty clear that it was in the legal ease category. Let's go to legal ease for 1200.
Watson.
What is executor?
Right.
Same category, 1600.
Answer. There you go.
That was the moment when I knew it's over.
The category is 19th century novelists.
What Watson wants to do then is preserve the lead, not take a big risk, especially with Final Jeopardy, because just like for humans, Final Jeopardy is hard for Watson.
Now we come to Watson, who is Bram Stoker and the wager. Hello, 17,973 and a two-day total.
And Watson won the main history. So it's pretty amazing because Watson has to recognize this speech and be able to find the best answer. So you can see from the video there were different scores. So what is happening is that it has information from many different sources and trying to rank which one is most reliable, most correct, and then he answered the one with the highest score. Watson, besides that, Jeopardy, they started to find more interesting uses of Watson. 20th Century Fox had a movie called Morgan. I don't know how many of you seen Morgan. It's a really scary AI movie. Okay, so anyway, so they thought, 20th Century Fox thought it was pretty cool. This movie is about AI. Why don't we use AI to create the trailer? So they hired IBM Watson to create the trailer for the movie. So let's watch this movie trailer that the AI created.
His first birthday exceeds our wildest expectations.
Nice to meet you, Morgan.
Nice to meet you, Thea.
I have a 13-year-old daughter. You don't get to see her much anymore.
Skip, don't go in there, okay?
What?
Don't you go down there, Skip.
Don't be afraid, Amy. I have to go say goodbye to Mother.
What do you think? Is that scary enough for you? So what they did is that they gave IBM thousands of other trailers that was considered to be good trailers for these horror movies. It analyzed why those movie trailers were good, and they analyzed each scene within this movie, assisted to find which scenes have which characteristics, and tried to match up and come up with a trailer that is successful. So that's pretty amazing using AI to create a movie trailer about AI. Watson has since gone to other areas. Medicine is another area that they've been working on heavily. It says that AI recommends same treatment as doctors in 99% of cancer cases. So that's AI is actually, so those are present day examples, but those are like huge applications. But in a daily life, AI is also very present in people's home. Some of you have Amazon Echo Dot. Any one of you have that at home? It's this very cheap machine. It's only like I think $30 US, and it is a very powerful AI that you can just put in your home.
Alexa, alarm on. Alexa, who's on the calendar today?
You have 12 events scheduled.
Alexa, call me Uber.
Your Uber will arrive in 2 minutes.
Alexa, what's the weather like today?
There's a 100% chance of showers.
Alexa, pair my Bluetooth speaker.
Okay, paired.
Alexa, it's time to reorder some paper towels.
Okay, order placed.
Alexa, play my garage music.
Play your garage playlist from Prime Music.
Alexa?
Play some jazz. Playing some jazz from Prime Music.
Alexa, who's this?
This is Picnic Basket by Lola Tone.
Alexa, turn that up. Alexa, ask Domino's to send me my last order.
Okay, order placed.
Hey, isn't that Jason Schwartzman?
No, that's not him. I would know if that was him.
I'm pretty sure it's him.
Okay, Alexa, who stars in Mozart in the Jungle?
Stars include Malcolm McDowell, Jason Schwartzman.
See? Okay.
Alexa, change the bedroom temperature to 65 degrees.
Okay,
Alexa, lights off.
okay.
Alexa, good night.
Good night. Sleep tight.
So that's